Hello everyone, welcome to our channel Coffee with Codes. Today we have brought another class on the quantitative aptitude section, and that is on HCF and LCM. Last week we made another video on the quantitative aptitude class 1 on the chapter number system. In that video we have explained completely the remainder theorem, which is very useful, and if you have not watched the previous video, please do watch it and then come and watch this video. HCF and LCM is itself a very good topic and a very important topic for all the examination that you may sit for, whether it's for your placement drives like HCL, Infosys, TCS, Wipro, Capgemini, Cognizant, or it's for your government examination. By making this video, our vision is to help you guys get a clear basic idea of all the quantitative aptitude chapters. We'll try our level best to make you explain over here, and still if you face any problem regarding this chapter, you can comment us below. Last week we asked you one question, that whether to make this video on English and Hindi, but we got maximum answer as English. So in this video we'll be using the language English, but don't worry. If you want us to make this in Hindi or in both languages, please let us know by giving your valuable comment to us. We love comments from you, we love to answer it, and we love to solve it. So don't forget to comment, and from here forth, Vishal sir will take you through HCF and LCM. He'll give you a very detailed and an understanding of this chapter. He'll solve all the basic concept of HCF and LCM, solving various problems and the short tricks that you can use for HCF and LCM in your examination. Trust me guys, if you want to crack any of these quant sections, you must know the short trick of each and every chapter. And for that, today Vishal sir will take you through all these short tricks and will solve various difficult problems that you may face in your examination. With this, let me hand over the video Vishal sir.
Thank you, Tejaswini ma'am. So first we will learn how to do HCF or GCD sums, and then we will do the LCM sums. So as you know, HCF means highest common factor and GCD means greatest common divisor. So let's move to our first question. So here is our question. Question number 1. The question is, find the HCF of 20 and 25. So let's start from the very basic concepts, that how to find the LCM or an HCF sum. How to do a HCF or a LCM sum. So as you know, first two numbers have been given here. So we have to find out the factors, prime factors. We have to find out the prime factors of both the numbers. So first let's see, we will find out the prime factors of 20, which is going by 2, 10, again it will go by 2, 5, and here it ends. So this all are the prime factors of 20, which is 2, 2, 5. And for 25, let's find out for 25, it is going by 5 and 5. So here, these are the prime factors of 25. So the prime factors of 20, let me write it again, 2 into 2 into 5 into 1. And for 25, it is 5 into 5 into 1. So the common factors are 5 into 1, 5 into 1. So the HCF, which is a highest common factor, will be the multiple of these numbers, which is 5 into 1, 5. So this is the highest common factor of our question. So we will solve it in the simplest way, which Euclid have introduced to us, that is the divisor method. So how to do that? So here the smallest number, which is 20, will be the divisor and 25 will be the dividend. So here we can say that 21 20 and it will go by 1 only, and 5 will come down. This is the remainder. So what we do the next step? We will divide the divisor again by the remainder. So it is going by 5 4 ja 20. So the remainder is 0. So this divisor, which is the last divisor is which gives remainder 0 is our HCF, which is 5. So this way we will solve each and every sum. So let's move to the next sum. So this is our question number 2. Find the HCF by long division method. The sequence of quotient from top to bottom is 3, 1, 3 and the last divisor is 6. Find the sum of both the numbers. So what should be the approach to do this sum? So we have to write the quotients. These are the quotient from bottom to top. Bottom to top direction. So this 3 will go to the bottom and this one will come in the middle and this 3 will go to the top. Okay, so you have to arrange the quotient in this format always, because here 3 and 3 1 3 it's look like a palindrome. That's why it is looking up and down same way. But if this would have been other numbers, then it would have been a problem. So this you keep this in mind always. So as we know, the last divisor is 6, and I have told you in the previous question that the last divisor which gives 0 is always the HCF. So by that concept we get to know that this is the last divisor and which will be multiplied with 3 and gives the remainder 0. Then only it's the last divisor of the HCF. So it gives us 6 3 ja 18. So this 18 will be multiplied with this quotient, because this is the divisor of the previous one. So and the remainder was 6, then only it became the divisor for the next one. So 6 will be added and it gives 24, and again we have to do the same thing, 24 into 3 plus 18, and which gives us 90. So find the sum. The question is find the sum of the numbers. So both the numbers, find the sum of both the numbers. So we have to do the sum of this numbers, which is equals to 114. So let's check. The starting two numbers was 90 and 24. To find this, the last divisor is 6 is coming or not. So let's check. 24 will be the divisor and 90 will be the dividend. So it goes by 3 and it gives us 72. So we have to subtract it. We will get 18. So as expected we get 18, and the divisor will be 18 and the dividend will be 24. So 18 1 ja 18. So this will gives you 6 and this is 18. So 6 3 ja 18 and it gives 0. So see, this is our HCF as told in the question. So we have solved this question in two different methods and showed you the back calculation to check your answer. So let's move to the third question. So the third question is find the HCF of 72 and 90. So you will tell me, sir, I have done this sum in the first question only. So why I am explaining it again? No, I am going to explain you one more simple way to do this sum. How to do that? So if two numbers has been given and if you have to find the HCF, so you have to subtract the bigger number. So you have to subtract the smaller number from the bigger number. So 90 minus 72 gives 18. So you have to check that this number is dividing both the numbers properly or not. That means if it is giving remainder 0, then this is your HCF. Otherwise, you have to continue finding the different factors and calculation, and you have to check it one by one. So in the next sum, I am going to show you that only. So keep connected with Coffee with Codes. So see, question number 4 is find the HCF of 216, 423, 1215, 1422, 2169 and 2223. So first we have to check that which number have the least difference between them. So I have checked here. See, this is nearly about 200 and this is nearly about 800 and this is nearly about 200 and this is also nearly about 1000, but these numbers have difference nearly about 50. So let's check it. It will be 9 minus 3 minus 9, that is 13, 9 minus 4, 4 and 5. So 54. So now we have to check that this difference which we have got divides all the other numbers or not. So let's start from the first number, 216. 54 divides 216 by 4. Yeah, 54 4 ja 216. So this is going. So the second number, see, the last number is 3 and 54 is the even number. So 3 won't come in any table of 54. So it is not going to go. So now what I've told in the previous question, that we have to find out the multiples. So first write the multiples. 1 into 54. This is the first multiple by which we are checking 54. And the second is 2 into 27. So we have to check that 27 is dividing the remaining numbers or not, because if 54 is dividing 216, then 227 will also divide 216. So it will also go by 27 also. So let's see, 27 divides this number or not. So 27 in 7's table, 3 we get in 9. 6 7 ja 30, 9 7 ja 63. So let's check it by 27. 27 into 9. So 9 7 ja 63, 3, 6 goes up. So 9 2 ja 18, 18 plus 6, which is 24. So it is less than, so we can check, it can go by 19 also. So 19 means 10 plus 9. So 10 into 27, which is 270, we can add this 2 and we'll get the 19th multiple, which is coming to 1, and this is 513. So this is bigger than this number, so it is also not going. So we have to find out the third multiple, which is 3 into 18. So we have to check this number by 18. But we have again, you can see that this is the even number and 3 won't come in a even number table. So this is also not going to divide it. So we have to find the next number, which is 6 into 9. 6 into 9. So here 9 will divide this. Let's see how it is dividing. So let's divide it. 4 2 3 divided by 9. So 9 4 ja 36 and 36, and it is going 6 3. So see, 9 7 ja 63. So see, in 47 times it is going. So 9 is the divisor of this number and this number. So for the next numbers, I'll use the divisibility rule of 9 to check that it is divisible or not. So let's see, 1 plus 2, that is 3 plus 1, 4, 4 plus 5, which is 9. So if the addition, the divisibility rule of 9 is, if the addition of the digits gives you the multiple of 9, then it is then it will be divisible by 9. So it is giving 9, that means this number is also divisible by 9. So for this, 1 plus 4, 5, 5 plus 4, 9. So again it is giving 9, that means it is also divided by 9. So here we got HCF is equals to 9. So for other tables divisibility rule, if you need it, then please comment us below, then we will make a separate video on the divisibility rule of all the numbers till 21, because ma'am has told you in the previous video that you have to remember till 21. So you have to know the divisibility rule, how to check it till 21, then it will be a very easy thing for you to calculate in the examination hall. So moving to the next question. So here is our question number 5. The question says there are 3 prime numbers. The product of first 2 numbers is 1891 and the product of last 2 numbers is 7991. So we have to find all the 3 numbers. So here we have to notice that all the 3 numbers are prime. That means it will be divisible by itself or by 1. And first 2 numbers product is this. So let's say the first number and the second number multiplies and gives you 81891, and for the last 2 numbers, which is 2 and 3, will give you 7991. So if this 2 numbers we have to find out the HCF, then by here only we can see that the second number is the HCF of both the numbers, because it is present in both the numbers, and as this is the prime numbers, then this is the greatest factor, and therefore we can conclude that HCF of these 2 numbers is the second number. So as we know, the second number is our HCF, so we can find out the difference of these 2 numbers and we will get the HCF of the 2 numbers, as I told you before. So the difference is coming 6100. 6100 is not a prime number, so we have to find the multiples, because as per the question, the second number is also a prime number. So 61 into 100 we can do. 61 is a prime number and 100 will not divide these 2 numbers. So 100 or the multiples of the 100 is not going to divide any number. So 61 is a prime number and will divide these 2 numbers. So this will be the second number, because this is the HCF and this is equals to the second number. So we got that the second number is 61. So we have to find out the first number and the third number. So how we will find out the first number? So first number will be calculated, that 1981 divided by 61, because this 1981 was the multiple of 1 and 2, and we know the second number is 61. So if we divide this second number, we will get the first number, which is 31. And for the third number, we have to divide 7991 by 61, which is going to give us 131. So these are all the 3 numbers which we have to find out in this sum. And I know the division is hard, but you have to practice a lot to get this division. And I'll look to the simple methods how to find division, and I will teach you, don't worry, in the next videos. So moving on to the next question. So here comes the question number 6, which tells find the greatest number which when divided 2, 410, 751 and 1030 gives the same remainder. So if you do it in normal method, then it will take a lot of time. So I am going directly to teach you the easiest method to do this sum. So how we will do? 410, 751 and 1030. You have to find the difference of both the pairs. So the difference will be 341 and 279. So after this, you have to find the difference of these two numbers also as 62. So here we have to check that 62 is dividing these two numbers or not. So see, this is an even number and this is, both the numbers are odd. So this is not going to divide. So we have to find out the multiples. So the next multiple will be 2 into 31. So see, 31 is dividing this number and this number. So 31 will be the HCF and this is the greatest number which will divide these three numbers and gives the remainder same. So we indirectly in this question also you have to find the HCF of three numbers. So this was the answer. So I hope you understood. So if you are facing any problem in understanding the concepts which I am explaining to you, so comment your queries and questions in the comment section so that we can help you with your questions. So moving to our last question, that is question number 7. The question says a farmer has 945 cows and 2475 buffaloes. He wants to gaze them in minimum number of groups in such a way that each group has only one type of animal and also contains equal number of animals in each group. Find such minimum number of groups. So how we have to approach this sum? So see, you have to find the minimum number of groups. That means you have to put the maximum number of animals in the group. That means the highest common factor. So we have to do the same thing for this also, which is 945 and 2475. So we have to find the factors. So let's find the factors. This number is going by 5. So it will give us 189, then it will go by 3 and it is going to give us 63, and again by 3 it will give us 21, and again by 3 it will give us 7. So these are the prime numbers, prime factors, and for this we have to do it again. 5, 4, 9, 5, and again by 5 only, so it will give us 99. Again by 3 it will give us 33, again by 3 it will give us 11. So from here we will get the HCF, that is highest common factors, which is 5, 1, 5, 1, 3 and 2, 3. See, 5 into 3 into 3. So it will give us 45, and we have to find the minimum number of groups. So the remaining in prime factors of the numbers will give us the minimum number of groups, which is, see here, 3 and 7 is left. So 3 into 7 plus 5 and 11 is left. So 5 into 11, so it is going to give us 73, and this is the minimum number of groups in which the animals will be divided. So this is our answer, and this is the last question of this video, and there are more questions of HCF which we will bring in our next video, because HCF is a big concept, so we have to make 2 videos on HCF. So keep connected with us and solve each and every question by yourself on pen and paper, then only you will learn it. And please give us a thumbs up if you like our videos, and please comment us if you have any query regarding the concept which we have explained till now. And if you are not a subscriber, please give us a thumbs up, and best of luck for your exam. And don't forget to press the bell icon so that you never miss a video from Coffee with Codes. Bye.